Good morning, everybody. How are you doing? I was watching some presentation recently about how to do good public speaking and how to get people's attention, and one of the ways was just to stand up on stage and be quiet. And that worked pretty well. That was good. Thank you all for coming. I am Andy Cohen. I am an architect here at SUGCON. I started at SUGCON in 2019, but before that, I started working on SUGCON at Horizontal in about 2013. Justin, is he in the audience? Justin actually interviewed me for my first SUGCON position way back then. I ended up, I worked at a couple of different partners, and in 2019, I saw a job opening at SUGCON on the sales engineering team, and I thought that I could take a break from doing implementations and get a nice cushy job as a sales engineer. And that didn't, well, it turned out that I did a few sales pitches and helped out on that side of things, but within about 3 months, I got pulled over into architecture, working on Experience Edge. So I got a great opportunity to work with Cam Figge and Alistair Dennis on Experience Edge, and that basically started my whole career here at SUGCON. So what we're going to talk about today actually has nothing to do with building SUGCON or XM Cloud or anything like that. I'm actually going to talk to you about how we build SUGCON at SUGCON. So if you wanted to learn how to do a good XM Cloud implementation, you're totally out of luck. So if you want to leave, I'm totally cool with that. So I'm going to pull back the curtain and talk a lot about some of the internals of how we came to some of the decisions we made and how we ensure that some of our services are up. And hopefully it'll be interesting. This also shouldn't be confused with Rob's presentation yesterday. What was it called?
Resilient integrations with XM Cloud.
Okay, yeah, so very, very, very similar. All right, so let me just get into a little bit of history. So like I said, in 2019, I joined SUGCON, started working on Edge. I had a silly idea to publish XM content to Experience Edge, and the idea was shot down pretty quickly. But it got revived within about 3 months. We built the Experience Edge connector, and then we started the XM Cloud POC not too long after that, in I guess it's about May of 2021. We started development in August, or actually that was probably planning. We didn't actually start dev until November, and it was March of 2022, where on stage at Malaga, no, I'm sorry, in Budapest, I demoed XM Cloud to you all. Who all was there for that? So a fair number of you. Cool, very cool. That was a lot of fun. And then we went GA with it in July of 2023. The POC, actually, this is some of you guys may have seen this slide, and it doesn't look like you can see it very well, but I found it kind of interesting. If you read this, it says, let's dig into the details. This is sent by Nick Wesselman. Let's dig into the details of what Ian has done so far, what our plans are, and how we can split the work. Late for you, Bart, and some calendar conflicts. Please try to make this work. Otherwise, let me know. We can blah, 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 blah. So you have the original people on the POC. So as Nick mentions, Ian Webster, who I believe at the time he may have been in services, but he was actually the one who started the POC. And then the rest of us joined, and we split up the work. And it was myself, Bart, Charlie, Ian, Jeff Isle, and then Nick. And this was our original backlog, Kanban board that we used. There's some interesting things here. I was looking through this, actually. So this was our ideas that we didn't actually get to implement in the POC. But what does it say? It says, as an architect, I can't even read that. It's awful. Can you guys read that? I want to validate the Windows container isolation on AKS. Is Bart here? Did we do that, Bart? Yes. We did that. So yes, we are isolated. So if any of you guys are wondering, you cannot do container escape from one to another. So that is a good thing. Another really interesting one is kind of what this whole talk is about, which is down this one. Basically, pull apart the POC and decide, do we want to do microservices development in event-driven architectures, which is what this talk is really about. So this is the team's presentation. You can see some of the folks down at the bottom. There was probably about 20 of us on this call. I think I saw Jake's picture in one of these somewhere. I don't know if Jake's still in the audience, but lots of interesting folks there. So the whole idea was that for XM Cloud was that we have these giant sprawling infrastructures, right? That you guys, it's not that dissimilar to what it is today. I think that that Colin and Peter were just showing something very, very similar to this. And it can be quite complicated and quite time-consuming to set something like this up. This is, I think I've shown this a million times, but this is a real architecture that I worked on for a large insurance company in Wisconsin. And I was very, very, very proud of this architecture. Just being able to create all these machines and have all this control over how all this is built. It was fun. We had it sitting on the board for a couple of months. It was the work of art. But the idea was to take something like that and replace it with the pieces that we got from a lot of our acquisitions. So, this is CDP replaces all that, right? At least that was the idea. You add in Experience Edge for delivery, and then identity for our authentication, and then what you have left really is what's in the yellow, which is the content management server and the databases. I think SearchStack probably should have been on there, but it's so much less, and so these were our original goals. I'll bring that to the forefront in a second. So right here, enable a developer to select a templated GitHub repository. Now this is the idea that Nick got. I think it was Nick. It was either Nick or Ian. I'm really not sure whose idea it was. But it was to take a GitHub repo and deploy it, right? That's the whole idea of what it originally was. It wasn't anything. The whole idea was nothing to do with pages. It had nothing to do with any of these SaaS apps. It was, let's bring a container to the cloud. That was really it. And do it in 5 minutes or less. And be able to publish the content to the edge. And then be able to redeploy it in 2 minutes. Make some changes, check it in, and have it automatically be deployed. That was the whole idea, right? This was GitOps or infrastructure as code. And so that's how it all started. So let's see, take that and make it into a black box. And if you're watching Liz's presentation yesterday, she mentioned a black box. Now, the problem with black boxes is that if you don't surface the exceptional things that happen, your users will get frustrated. So what we do on deploy is and what we've gotten better at over time is surfacing those things that developers encounter to the end user. Right? We're trying to make it as simple as possible and actionable for you so you guys can do stuff. Not only for you, but for us at Sitecore as well. It it is hard if the developers are spending their time troubleshooting stuff where you guys could do it yourselves. So we're trying to put a bow on it. And we're constantly learning and trying to make this better. We are trying to reduce development costs, reduce site maintenance and infrastructure costs, improve marketer productivity. I think that there is a presentation by Catherine later today. Is it today? I think it's today. Is she here? No, she's not. But Catherine presents on, I think, something like bringing 6 or 7 sites in 6 weeks, something like that, using XM Cloud. We're also trying to prevent you guys having, right there, Catherine. And we're trying to do future upgrade cost avoidance and rapidly adopt new disruptive tech. We want to keep releasing very, very quickly so that we can bring features to you and provide even more value to you. Some quick statistics. So in deploy, I was looking at this. In the last 30 days, there was 10,000 customer deployments. So deploy is used very, very heavily. We have the average new environment deployment time still is about 5 minutes. It can actually go faster than that, depending on the size of the code, and it can go longer. But we still have an average of about 5 minutes. Here's an interesting fact. The .NET build now takes about, just the build portion of it takes about 30 seconds. And our JavaScript builds take about 2 minutes because of all the NPM packages it needs to pull down, which we will be working on optimizing that. We have had 128 base image releases in the past 2, and I think that this is just since GA, right? So this is since July of 20. This is only a little over a year. And then we auto-update you guys at least once a month, sometimes a couple of times. And then 2 years later, we are still on version 1 of the base image. So we have been able to successfully release without a breaking change that we couldn't roll back. So I think that this is it's a pretty good accomplishment for us. And then we also have a change log that not only goes through what we do in deploy, but the base images and all the other composable products are on the change log. If you guys haven't seen that, just go to Google, Sycor, change log, and you guys can check it out. So what really enabled deploy and XM Cloud to be a thing were all of the things that happened before. Container development. I think Bart had a huge part in this. Bart and probably a few other people in this room. All the headless SDKs, Sycor Team X, you guys probably know a lot of those folks from that. Static site generation, Experience Edge, and then all of the acquisitions. This is what really made XM Cloud a possibility. So all of the work that was done before I even came around, right, and before the team of architects helped out with deploy, like all of this stuff made it possible. This was our, again, we're still in the Teams video from the demo presentation to leadership to give the results of our POC and to try to pitch it and be like, hey, can we do this? And so Ian was demoing this. And this was our first Auth0 login screen. This was the first project screen. This is where you choose a template. And we had progress going on. This build took about 5 minutes and 8 seconds. All of this stuff here, this was just garbage that we were just outputting. So that wasn't real, but some of it was real. So we had scrolling text, so that was cool. It's not that different, really, from what it is today, and there's improvements coming all the time. But, you know, what was next, right? We did this demo. Leadership thought it was pretty cool. I think that leadership thought this is going to be our way into SaaS, and we were all super excited, right? We were all like, let's go do this. This was a major victory. We did this POC in 6 weeks, and we're going to do this thing, right? We're finally going to take Psycho to SaaS. And after that was just sheer terror, to be honest, right? Because we actually had to build it for real. And unfortunately, Ian, the lead architect on the project, was pulled off of it. Giannis, I think, pulled him into some other project that he wanted to work on. I don't think Giannis is here. I don't see him. But he pulled Ian off, so they put me as the lead on it. And this was my next state of mind, which just... I don't know if it was confusion. It was more of... I wasn't sure where to go with this, right? I wasn't the lead on Experience Edge before, and I hadn't led a project of this scale before. I hadn't started microservice development really from the ground up. So it was a huge opportunity for me to figure this out. And so what did I do next? I read. I'm not comparing myself to Bill Gates, but what I did is I read a lot of books. And I'll show you some of the books that I read as a recommendation for you guys. But really, I needed to figure out, how are we actually going to build this? How are we going to build it for real? And not only that, after you build it, how do you keep it up? How do you keep it running? And as you'll see, there's a little bit of nuance to those things. As John Malone, who runs our platform right now, there's a lot of nuance to what is up. From your perspective, if it works or if it doesn't is up. But the answer is it kind of depends. So let me just start with some of the basics. And this is really kind of high level. It's a mixture of high level and probably a little bit too much detail in some places. But this is stuff that I get to, I guess, nerd out on. It's stuff that I care about. So you're just going to have to sit there and listen, or like the door's over there again. So what did I do first? I needed to figure out, what is the architecture on this thing? What is it going to look like? This is not working anymore. There we go. So what is the architecture? I could go a couple of different ways. I could do a giant mono repo, a giant monolith. I really didn't want to do that. I ended up looking into microservices development because I was very fresh in my mind, having come off of Experience Edge. And I also really was into event-driven architectures. And because Experience Edge is built using Confluent Kafka to send messages from one place to another. So we use it for an event system, and not only that, we use it as a streaming platform. So you can stream thousands and thousands of events or messages per second in Kafka. And it was a good choice, not because deploy actually does and needs to send lots of events with the volume that we were expecting, but the one reason, or there's two reasons we chose Kafka, really. It was because we wanted to stream messages, right? We wanted to show live deployment logs, and Kafka was a really good choice for that. And the other choice was it existed in our tech stack already, right? So that's a good reason. If people know how to use it, right, you got to take that into account. Do you have people that can actually support the tools that you're proposing to use on your next project? So always keep that kind of thing in mind. But I read these 3 books, Building Microservices, Building Event driven microservices. And then one of my favorites really is this third O'Reilly book, which is actually, it's an ebook only. And you can download it from the Confluent Cloud website. You guys should really take a look at that if you're interested in learning about this. The author is also really, really approachable if you guys reach out to him on Twitter or if you could find his email address. Again, we chose Kafka because this example orchestration that you see on the right here is not that different from how things work in deploy, right? We have, in a couple slides later, you'll see what the architecture actually is. But it was long-running processes that run in the background. We needed to communicate between various different domains and microservices. And we needed to make them resilient. And Kafka is a really good choice for this, and I'll show you why in a little bit. And it existed in our stack. Along with that, I read, this is a very dense book. I did not read the whole book. I read parts of this book. But Domain-Driven Design Distilled. Understanding what the different domains are is really, really important when you're doing microservices. And on this next slide, I guess let me kind of break down how I think about the different domains that you could do. So lots of developers would probably think that the domains should be sliced apart between the different microservices. You know, we have the monitoring worker where we stream all of our messages to, so we can have live logs that go either to the user or into storage. We have a tenants worker, deployments worker, the builds worker, the builds pipelines. You could split things on those domains, but you also may want to also have a user domain. Like what are the entities, what are the models that the user actually thinks about things? Like what we have in deploy. We have an organization, we have projects, we have environments, and we have deployments, right? Those are our main domain models, completely stolen from how Vercel does it. That's where the model came from, but that is our top-level domain. And so we created a microservice specifically for that, our top-level API, which we call internally our GitOps API. It's still, I think, it's the GitOps project. And we have separate repositories for each one of these things, and we build separate libraries, and we end up taking all of them, and we deploy each one of these independent of one another. Yes, we use search stacks and Azure SQL, Kubernetes, and Vercel was the only thing we could deploy to. You could technically deploy anywhere, but Netlify, Vercel, Azure, self-hosted, whatever you want. You can, as long as you can deploy a Node.js server, you can deploy our solution. So what you saw previous, a really, really high level, turns into this, showing all of the ways that things go around. The really important thing was this, which was very, very similar to that, which is why why we're using event-driven, really. Because we mapped out what are the different things that needed to happen to communicate between the different microservices. And what are the topics that you need to have to produce those messages to so that you can consume them and process them. And maybe you haven't used Kafka and you maybe don't know what some of those mean, or those words I just said mean. I'll go through that in a little bit. But we converted this high-level orchestration pattern into a really complex state flow diagram to understand, and so that we could take the ideas that we had in our head and these really high-level things and turn them into something that developers could read. We actually created this using Plant UML. I don't know if you guys are familiar with it. It's basically a YAML-based system that you can create a diagram like this. There's other tools that you can use to do diagramming. This this worked really well. There wasn't a really good like default diagram in plant UML. How much time do we have? I have no idea. 20 minutes left? Or okay, all right. So we used plant UML, and this is a zoom in on it. You probably still can't read it, but we broke it down into the different domains at the very top, and then in each one of these we had what's the state. So like, what's the databases that we have? And each one of our microservices has a different database using Cosmos DB. And we have different topics that are owned by each worker. And then we also represent the worker. And then how do the messages flow through in between them? So what are the things you need to know about Kafka? So number one, a topic, right? A topic is where you send messages to. Topic is nothing but a log file. You can think of it really as a giant text file, right? That is really fast reads and really fast writes. There's a concept of producers where you produce messages to the topic. And then you have consumers which consume messages from the topic. They read from the topic. Then there's this thing called consumer groups. The thing about consumer groups and the way that we use them is that, let's say you had a named consumer group called the builds consumers. If every one of your pods that are running use the same consumer group, when you consume a message, only one of those pods is going to pull that message across the entire consumer group. So the next message that comes down will go to a different consumer group, or I'm sorry, go to a different pod. And in this way, you can make use of concurrency, right? But you can ensure that the same message is not going to be put on multiple pods, right? And be processed twice. That's the key to this. And then, speaking of keys, there's this thing called keys, which is something that you can use to order your events. If you think of a key in the concept of consumer groups, I visualize it in my head as there are a bunch of different doors, and each door has a number on it. And like if my message, all of my messages have the key of number 1, they're all going to go through the same door in that order, right? That's the way that I think of it. So you can have all of your messages flowing through order, staying on one pod at a time. And those may jump around, but it all depends on this thing called brokering and partitioning. Don't need to really go into too much detail. We also have control over our commits, which is where the resiliency comes in, which is what I'm talking to you guys about this right now. So we use Kafka to process messages, and we're using long-running tasks like create the infrastructure for a tenant, provision the SQL databases, add the edge tenant, add the identity clients, all those things. These things take time. We do all those operations in parallel. But then at the same time, that this is going on in the tenants worker, over here in the builds worker, we're running our builds. And those can take up to, if we do the .NET at the same time as the rendering host, that takes up to about 2 minutes on that build stage. And so these two things are happening concurrently, and whichever one finishes first is actually when those things actually happen, or when they both complete, that's when the deployment happens in the deployments worker. But what happens when things go wrong, right? That's the problem, right? So what happens when things go wrong? What happens if a developer checked in some code that exposed some kind of latent bug that causes an out of memory on the pod that's running this long-running task, right? And so I've started a build, and then all of a sudden the pod dies. What should happen? Well, in Kafka, you have this thing called commits. And in Kafka, you're basically, as you process messages, you say, this message is done, this message is done, this message is done. And those are your commits. And Kafka stores the offset, which is the commit. And imagine in normal Kafka, or like by default, it does this thing called auto commit. So you pull a message off and it commits it immediately. But what we do is we take control over it. And we don't commit the task until it ends. So that means if the application breaks down right in the middle, when it comes back up, it's going to start over from what the last commit was. So it'll pull down all the messages that it had until up to where that last commit was. So it'll start over again. So because that process didn't finish during the middle of that long-running task, it'll start over on that task again, or maybe 10 tasks behind, depending on how many we had in progress. So what this translates into is you have a build running. It died. I need to run it again. I will not commit it until that build is actually completed. So this gives us a level of resiliency to ensure that things actually complete. I don't know if this is a common pattern, but this is a pattern that emerged in Experience Edge. We do the same thing there, and so I brought this over to deploy. I think it works really well. I don't think that our identity team does the same thing with the commits. I think what they do is if there's any exceptions, they won't commit it, and they'll maybe forward it to another topic. I'm not sure. But each of our teams kind of does this a little bit differently. This is how we do it in deploy. Now, deploy also has a ton of dependencies. Now, when you introduce a lot of dependencies, you a lot of times need to have backups for a lot of those dependencies, but you can't have a backup for all of your dependencies all the time. So let me just go through some of these dependencies, and I'll tell you about a common one that's happened. So Auth0, Psycho Identity, Edge Provisioning, GitHub. This is where the example that I'm going to bring in pretty shortly. How much time do we have? 10 minutes? 5 minutes? 10 minutes. OK. So GitHub, Azure DevOps, Azure SQL, Cosmos, Azure Container Registry, and then Kafka. And each microservice that we have has they depend on some of these, some of them not. There may be some other different ones I didn't mention. But the point is, we have a lot of dependencies. So what do you do? How do you make sure that your application functions when you're depending on all this other stuff? And this is where this uptime calculation really comes into play. I'm not going to tell you how we calculate our uptime. I'll say that for XM Cloud, if you read our SaaS SLA, it says that we calculate our uptime based on 4 areas: delivery, publishing, authoring, and then deploy. I would also say maybe we should add authentication in there. But we actually weight our SLA based in order and based on those different things. And if you want to read about it, you can. We take all of our dependencies, and we created health checks for every single one of them. And these are the health checks. This is on our components health check on our main GitOps or deploy API. Builds, configuration, deployments, inventory, monitoring, pages, provisioning, container registry, et cetera. And this is an example of one of them. We also have lots of internal health checks, but this one is meant to be consumed by the public, and which is why each one has a very descriptive text that's actually shown. Like, for example, container registry and deploy shows up like this on our status page that looks like this. And each one of those components looks like that, right? And this changes over time. We add different things in, we take things out, we modify it. But the point is, we show automatic status based on our dependencies. We change how our application actually functions. So our GitOps API is pretty much up all the time, but the functions, like our dependencies, could go down. So what should we do if a dependency goes down? Should we just take down the whole API? Right? Let's say we had a health check on our liveness probe, and I think in Kubernetes, and I'm going to get this wrong because I'm not a Kubernetes expert, but I think it's the Leibniz probe. If that isn't functioning, then it's going to stop network traffic. Is that right, Bart? Yes. Readiness. Okay, I got it backwards. Sorry. All right. So it's going to stop network traffic, and we kind of do the same thing. So, for example, we did I show that? I'll show it in a slide later. We wrote an attribute so that if one of the dependencies is down, if a certain endpoint relies on it, we will return a 503 service response status code when it's not functioning. So this is our create deployment endpoint. If you try to create a deployment and Azure Container Registry is down, it's going to return a 503. So our whole API isn't down, just that one endpoint isn't down. Now that works in some cases, and the whole idea here is that if you know it's not going to function, don't allow users to do it. Why should we allow a user to go through all this 10 minutes, 5 minutes, whatever, to do something if we know it's going to produce an error for them? Let's show them an error right away and stop it from happening to begin with. Our API is up, but we're not going to allow that thing to happen. Another thing that we did is that following the same principle that Kubernetes has, where it stops incoming traffic if things aren't ready, like what would you do with Kafka? Kafka is just sitting there pulling off a topic and reading messages all the time. So we wanted to bring that same concept that Kubernetes has to that, but there isn't any out-of-the-box module that makes Kubernetes function the same way. So we created a conditional background service. So there's background services in .NET, and we created our own wrapper around it. And then we created, you can't read this at all, but it's called a consuming background service. So what we do is we tie to our consumers. We wrote a class that tied health checks to different consumers. So we stop processing messages, we stop reading off a topic if the dependency isn't healthy. That's the idea. And so we can be really, really targeted to these things. And let me kind of explain how this works. Let me just fast forward here. So at first, what we used to do is if GitHub wasn't down or wasn't up, if it was unhealthy, we would just take out the builds worker, right? GitHub isn't working, builds worker, dead. That's not a very good pattern because there are a couple of different things that happen in the builds worker. Should we stop all work in the builds worker? No, you really shouldn't. So our next iteration of this was if you stop the builds worker, or if GitHub isn't working, what should we do? We should stop consuming. The builds worker is still working, but let's stop consuming. The next iteration we did of this is we said, oh, we do lots of things. We do GitHub builds. We do Azure DevOps builds. We do CLI uploads and do builds that way. So if GitHub is down, let's only stop consuming on a specific GitHub consumer. So the pattern is that you can be really, really targeted for how you build your application and stop doing the things, stop functioning of very, very specific things. We also take this now to regions. If we know that Azure Storage isn't functioning only in East US, we'll stop consuming messages for only East US. We won't stop the whole app because in West Europe, some service isn't working, right? So we do this all throughout. In all of our workers, we do the same kind of pattern. Yeah. So the basic idea is we consume off an operations topic. We see the message is deployment created. We ask what kind of a deployment it is. We see it's a GitHub deployment. We create a deployment created for GitHub message. We produce it back on the operations topic with the same key, so it stays in the same order. And then as long as that consumer that's reading the deployment created for GitHub is operating properly, it's going to process those messages, and so on. What's the region? US East. I'm going to forward it. I'm going to create a deployment created for US East message, and I'm going to put it back on the operations topic. We have a specific consumer group that's going to read for East US. Right? We have different ones for every single region, and this is basically how the flow of our applications work all throughout. And this is what enables us to make sure that we can target the operation of our app. We create, another thing that you need to be aware of is that we create the health checks with the best information that we have. So Symposium, last year, 2 years ago, I don't remember, it was in Chicago. Charlie and I were, it was before I was supposed to go on stage and demo deploy, and GitHub was down. So we were all kind of freaking out, and we were trying to figure out what do we do, but the example was like, so if you look at the GitHub status page, they actually have a bunch of different pieces or different components that they have in their API. Not only do they have this top-level GitHub status, but they also have a components health check, which is where we got the idea to break this down. And they have one for API, and this is what we actually depend on. But the API is rather large, right? And they don't give you a way to they don't give you a way to target very specific endpoints in the API. It's like the Azure Management API. It's gigantic, right? But the function that you want to use may still be working. So Charlie and I were playing around with this, trying to figure out how we're going to get this to work. I'm not going to be able to do my demo. And so Charlie ran the deployment in a lower environment. Now the problem was we had a health check on GitHub, so we couldn't deploy, right? It just wouldn't, in all of our environments, we couldn't. This was hard-coded in there. And we needed a way to react. So right before that, I literally was like writing code to override this health check so that I could deploy. Not really a good practice to do that kind of thing. So you need to plan for what if your health checks are a bit too stringent, or what if they're not good enough, right? So we use Azure App Configuration, and we use a couple of different things. We use I can't see feature manager. We use the feature manager, but we also use the configuration explorer. And we created an override. We created this section where we can create a feature like deployment health check override, GitOps health check override. So we can override the health of a whole microservice, or we can override the health of a specific health check in one of the microservices, like Cosmos. I should have used GitHub as the example. But we can override something as healthy. We can say it's unhealthy at any given time, or we can do the opposite, say something that's unhealthy and make it healthy. And the learning was that our health check for GitHub was hard-coded. We didn't want to do that, and it actually worked. The thing that we needed to do actually worked. So this kind of thing actually happens a lot. Like we'll get, every single time the state of our applications change, or our health checks, if any one of them happens, we get an alert that fires. And somebody gets woken up, or maybe it's during business hours, and we'll need to react. And they'll test it out, and maybe they'll need to go and update this. Anyways, we're out of time, so I'm going to just go through a couple of tips that I have. Your code is going to need to be constantly changing, so make sure you build your solution in a way that you can do that, like have things like Azure App Configuration. Make sure that you split your microservices on the right domains. This allows you to split up the teams in the right way. It allows you to fix things in isolation of other things, or develop new features in isolation of other features. And it allows you to deploy quicker and deliver value to your customers quicker. We use continuous delivery with feature toggles. So a developer will check code in. They'll have a feature toggle around it, and it'll get approved, tests will run, it'll get promoted all by itself all the way up to production. It gets turned on by a product manager and an architect. What you'll also find is that as you're doing microservice development, certain patterns will emerge, right? If you have a lot of microservices in your system, it's over, she's saying, the end. So I'm just going to I'm just going to go a little bit real quick here. You'll find that you'll need to have common patterns will emerge. Create libraries. It sounds like an anti-pattern, but it's really not. .NET, it's a shared library, right? It's okay. Release common libraries with breaking changes, or without breaking change, not with, without breaking changes. You can use your packages props file to have like one.star, so it'll pull in packages as you need them to all of your microservices at the same time. So you fix a bug in one common library, it automatically gets upgraded in all the others the next time you deploy. And then don't let your microservices get too big. You'll end up with macroservices. Watch out. And then always retry. Use something like poly, always retry. We don't have time for questions now. Sorry, I talked way too long. But you guys can talk to me afterwards. And I want to say thank you to our sponsors. And thanks for listening to me rant.